Have you ever looked up at a city skyline and seen one of those old-timey wooden barrels sitting on a roof? Well, today we're going to pull back the curtain on the brilliant engineering hiding in plain sight right inside every single one of those water towers.
Right? I mean, when one of the world's most famous astrophysicists gets fired up about something as ordinary as a water tower, you know there has to be something incredible going on. So what's the big secret?
So what is it that Neil deGrasse Tyson is so passionate about? Well, before we can really dig into the physics, we've got to get on the same page, because the term water tower can actually mean a couple of different things.
You've got those huge, sometimes even futuristic-looking towers you see in the middle of a town, but for our purposes, we're really focusing on those classic wooden tanks you see sitting on top of city buildings. But honestly, the science we're talking about, it's the same for both.
So what's the #1 job of a water tower? Well, you can think of it as a fantastic safety net, one that's powered by the most reliable force in the entire universe, gravity.
It's such a simple, elegant system, really. See, the building uses electricity to pump water up into the tank. But what happens if the power goes out? No problem. Gravity just takes over, pulling all that stored water down to your faucet. It guarantees you have water pressure, at least until the tank is empty.
Okay, but that leads to a really obvious question, right? It sounds kind of wasteful, doesn't it? Why go to all the trouble of pumping water up just so it can fall back down? This is where the engineering gets really, really smart.
The real genius behind that tank on the roof is all about handling peak demand. You know, that moment in the morning when it seems like every single person in the building decides to take a shower at the exact same time?
So instead of having some monster pump in the basement that has to kick into overdrive every morning, the building can use a much smaller, way more efficient pump that just slowly fills the tank over time. That tank acts as a buffer, a big reserve of water that's ready to go instantly when that shower rush hour hits. It's all about being efficient.
But here's my favorite part. The coolest bit of physics isn't about backup power or efficiency. It's a design secret that's totally visible to anyone walking on the street below. You just got to know what to look for.
If you look closely at any wooden water tower, you'll notice something kind of weird. Those big metal bands, the hoops holding the whole thing together, they're not evenly spaced at all. And to understand why, let's just imagine for a second that the water inside is split into 3 equal parts.
Okay, so let's just say the top third of the water in that tank weighs about 500 pounds. That water is pushing outwards on the wooden walls of the tank. Simple enough.
Now, let's go down a bit, to the 2/3 mark. At this point, you've got the weight of that middle section plus the weight of the top section pushing down on it. So the force pushing outwards on the walls is now double, 1,000 pounds.
And you see where this is going, right? All the way at the very bottom of the tank, the entire column of water is pressing down. That's a total of 1,500 pounds of force. The pressure is absolutely immense at the base.
So this phenomenon has a name, of course. It's called hydrostatic pressure. And all it really means is that the deeper you go in a liquid, the more pressure there is. It's just the weight of all the water above you pushing down.
And that is the big secret. That explains exactly why the hoops are designed the way they are. Up at the top, where the pressure is pretty low, the hoops can be spread far apart. But as you go down and that pressure gets stronger and stronger, you need those hoops packed tightly together to keep the whole thing from bursting open.
And this brings us right back to Neil deGrasse Tyson's warning. This isn't just about looks, it's a critical life-or-death design feature. If those hoops were evenly spaced, it would mean the bottom of the tank is dangerously weak. It's literally a public safety announcement written in steel and wood.
So you might be thinking, okay, I get it. But then you look around and realize, wait a minute, not every building has one of these. So what gives?
Yeah, it turns out that in a lot of cities, if a building is under, say, 6 stories tall, you probably won't see a water tower on its roof. So where on earth is their water pressure coming from?
And the reason is just so simple, it's almost funny. The city's main water supply, its reservoir, is already built on a hill or some other high point that's higher than the building's roof. So the water is just falling using the exact same principle of gravity, but on a massive citywide scale.
And you know what? This is not new tech, not by a long shot. The ancient Romans were absolute masters of this. Their incredible aqueducts were engineered with a perfect, gentle slope, letting gravity alone do all the work of carrying water from miles and miles right into the city.
So there you have it. The next time you're walking down a city street and you see one of those water towers, you're not just going to see some old wooden barrel anymore, right? You're going to see a beautiful example of physics at work. It's a great reminder that once you know what to look for, you start to see that brilliant engineering is literally everywhere, hiding in plain sight.